So my dear friends, after the first order reaction getting over, we now go into the next part, and that is zero order reaction. Okay, now what do you mean by a zero order reaction? That is what we are going to consider. Zero order reactions. Okay, now in this we go into the integrated form. Integrated rate law. So rate R is equal to nothing but it's given as minus of dA upon dt, where we say A is giving products. So that is nothing but equal to K into A raised to 0. So that is equal to K. Because anything raised to 0 is 1. Okay, it's a zero order reaction. So that means it will be A raised to what? 0. Okay, मालूम है ना आप लोग को x is nothing but is the power is nothing but the order of the reaction. तो उस हिसाब से what we can say is therefore minus of dA is equal to k dt. Okay, ये dt को मैं वो बाजू लेके गया. So therefore we can say dA is equal to minus of k dt. ठीक है, अभी इंटीग्रेशन करेंगे हम लोग. Our integration आपको मालूम है within the final and the initial limits. So when t is equal to 0, the concentration which I have is A0, and when t is equal to t, the concentration which I have is AT. So therefore, when we carry out the integration of A0 to AT, it is this is equal to minus k, it's constant, so it is 0 t dt. तो जब इसको हम लोग सॉल्व करेंगे तो we have final minus initial, so therefore what we have is AT minus of A0 is equal to minus of KT. Okay, ऐसा मिलेगा हमें AT minus of A0 is equal to what? Minus of KT. अभी तीन टर्म्स है मेरे पास. I multiply each of these terms by what? My negative sign. So as a result of which what I'll be getting is, I'll make it as KT is equal to, I make it this as plus, okay, because I want to start off with a plus sign. So minus minus becomes plus, and this will become minus of AT. ठीक है, multiplying each particular term by minus sign, so minus of minus will become plus. Here be minus of minus A0 will become plus A0, and this will become minus of AT. So KT is equal to A0 minus of AT. ये मिलेगा. So therefore, what can I say is K will be equal to A0 minus of AT divided by what? T. Okay, K is equal to what? A0 minus of AT divided by T. तो अगर इसका units हमें find out करना है, what will be the units of K, and that is nothing but what we do is the concentration terms are expressed in moles per dm³. So I'll say moles per liter upon time. So that is equal to nothing but we can say moles, liter inverse and time inverse. This becomes the units of K. और अगर दोस्तों अगर आपको याद है यही था units for the rate of the reaction. So that is equal to the units of the rate of a reaction. Because rate of the reaction also says the same thing. It is a change in the concentration to the change in time. Okay, so concentration upon time. So concentration is expressed in terms of moles per liter upon time. So mole, liter inverse and time inverse. That will be the units of K, that is rate constant. That is equal to the unit of the rate of the reaction for याद रखो कौन सा? Zero order reaction. ये भूलना मत. Okay, first order reaction के लिए हमारे पास expression अलग था. Okay, वहाँ पर हम लोग ने बोला था it is time inverse. लेकिन यहाँ पर it is moles per liter time inverse. आई बात समझ में? Alright, so I guess up to this part is very clear to you that what is exactly is the zero order reaction and how we are coming to the integrated rate law for the zero order reaction. अब हम डिस्कस करेंगे दोस्तों जीरो ऑर्डर रिएक्शन के लिए, एंड दैट इज अबाउट द हाफ टाइम. हाफ लाइफ का डेफिनेशन तो अभी मुझे आपको बताने की जरूरत नहीं है, आप सभी को पता है अच्छी तरीके से कि इट इज द टाइम रिक्वायर्ड फॉर द इनिशियल कॉन्सेंट्रेशन ऑफ द रिएक्टेंट, whatever is the initial concentration of the reactant उसका हाफ हो जाना चाहिए. So the time required to reduce the concentration to half of its initial value. Alright, तो अभी हम लोग कंसिडर करेंगे once again the same expression and that was A0 minus of AT that is equal to KT. So therefore K will be equal to nothing but A0 minus of AT upon T. Now you also know very well that when T is equal to T half, AT, the concentration of the reactant reduces to what? Half of its initial value. So that means it will become initial value is A0, half of it is A0 by 2. तो ये एक्सप्रेशन इसमें सब्स्टिट्यूट कर दिया जाए तो मुझे मिलेगा फिर therefore K will be equal to A0 minus of A0 upon 2 divided by T half. Okay, so that means it is equal to nothing but 2A0 minus of A0 upon 2T half. So that is equal to A0 upon 2T half, and therefore we say T half is equal to nothing but A0 upon 2K. Okay, that is what we need to consider. T half और K, okay, उन लोगों का पोजीशन हम लोग एक्सचेंज कर देंगे. So T half is equal to A0 upon 2K, and therefore we say that the half life, yeah, half time is proportional to the concentration, and which concentration it is? The initial concentration of the reactants. अगर आपको याद है दोस्तों, जब मैंने आपको फर्स्ट ऑर्डर के लिए बताया था, दिस इज फॉर जीरो ऑर्डर, फिर मैंने जब फर्स्ट ऑर्डर के लिए बताया था, सो इट वाज टी हाफ इज इक्वल टू नथिंग बट 0.693 अपॉन के. सो इसका मतलब ये हो जाता है कि इट इज इंडिपेंडेंट ऑफ द इनिशियल कॉन्सेंट्रेशन. लेकिन यहाँ पर हम क्या बोलेंगे? इट इज गोइंग टू बी प्रोपोर्शनल टू द इनिशियल कॉन्सेंट्रेशन, दैट इज A0. अभी हम लोग जाएंगे ग्राफिकल रिप्रेजेंटेशन पे. With respect to once again the same thing, zero order reaction हम लोग कंसीडर कर रहे हैं. So we go for the graphical representation. We once again go for the formula, and that is A0 minus of AT is equal to KT. So therefore I can say AT will be equal to nothing but KT minus plus A0. समझा आपको? AT इधर चला गया, KT को इधर लेके आया, तो AT is equal to minus of KT plus A0. तो ये इक्वेशन कैसे हो जाएगा दोस्तों? This is an equation of the type y equal to, मैं ये T को ऐसे लिखता हूँ, otherwise you will find, तो K is M, the G is X, and this is C. So y is equal to mx plus c. इस तरीके का ये इक्वेशन है. तो we plot a graph. Y-axis is the concentration of the reactant at a time. Next is the time. Okay. Now there is an intercept. ये minus of k is a slope. तो slope जब negative है तो we will be showing like this. ये इसका slope हो गया. So slope is equal to minus of k, and therefore we say k is equal to minus of slope. और ये जो intercept है on the y-axis is nothing but the initial concentration. So concentration at the particular time intervals, ये हमें plot करना on the y-axis against what time on the x-axis, and the intercept मुझे मिलेगा, वहाँ से मुझे initial concentration मिल जाएगा. Initial concentration मुझे मिलेगा plus मुझे k भी मिलेगा, तो इधर डाल देते तो मुझे t half भी मिल जाएगा फिर. Okay, I can get A0 from here as an intercept. I'll be getting k as what? Minus of slope. So accordingly, we can go into nothing but what? K. The formula is over here in front of you. तो हम लोग half life भी calculate कर सकते if you plot a graph of this way. Alright? तो I guess आप लोग को ये graphical representation and half life समझ में आया है with respect to the zero order reactions. अब दोस्तों कुछ सिंपल एग्जांपल दे देता हूँ आप लोग को. for a zero order reaction? Examples of zero order reaction. और वो है अमोनिया, उसका हम डिकम्पोजिशन करेंगे इन ऑन द सरफेस ऑफ अ मेटल कैटलिस्ट, और वो हमें देगा N2 plus H2 in the gaseous state. Okay, if you balance the reaction, so this is what we get. So ये zero order reaction, that means what happens is the decomposition of ammonia is not depending on the concentration of ammonia molecules. Okay, so whatever is the concentration of ammonia molecules, the decomposition reaction will go on. Okay, because it's all taking place on what? The metal surface catalyst. Similarly, अगर nitrous oxide मैंने consider किया, that is N2O, उसका decomposition से on a platinum catalyst, it is going to give you N2 plus O2. Okay, so this is what we get. It's once again a gas phase reaction, and the catalyst is going to be a solid, so as a result of which this reaction takes place. And once again, the decomposition of nitrous oxide actually doesn't depend upon the concentration of nitrous oxide, और इसलिए हम लोग इसे बोलते हैं zero order reactions. समझ में आया आप लोग को?